In this video, we're going to continue our discussion of transformations that we did way back in the fall with linear functions. So in a linear function, if we had a straight line, a transformation was anytime we move this line. So we can move it up, we can move it down, we could have rotated it, we could have reflected it, all kinds of different transformations. With quadratic functions, now we're taking our parabolas, which are these U-shaped graphs, and instead of doing a lot of transformations with them, we're only going to do vertical translations. So we're going to shift them up and down. So we need to be able to look at their equations and understand what's going to happen to the graph. So first of all, some vocabulary words. We saw this word parent function when we dealt with linear functions. For a linear function, f of x was equal to x because it just had to be to the first power. So it was just x. And that's what we did when we dealt with linear functions. Now we're dealing with quadratic functions, so our parent function now must have x to the second power. And this is just the most basic type of function. And then when we put other numbers in here, I don't know, maybe a coefficient, maybe something else, that's going to change the shape of the graph. So what we're going to be looking at are just these vertical translations. So we're just going to slide it up or down, and that's going to be a vertical translation. So the way we do that is, again, we're always starting with the graph of the parent, unless they tell us otherwise. And anytime we add or subtract a constant out here, just like with linear functions, that moves the graph up or down. So it's kind of like our y-intercept, just like before. So whatever this number is, if it goes up, then again, the graph will shift up. If whatever that constant is goes down, then the graph shifts down. So again, it's just like linear functions from before. So in example number 1, remember the parent is just f of x equals x squared. So we can look out here and see that there's nothing there, which really means it's plus 0. So if I look at my new y-intercept, I can see that 0 went up 4 units. So the graph of f of x was translated up 4 units. And that's a vertical translation. Okay? It's the same thing over here. If we start with that parent function, again, since there's no constant out here, it's kind of like it's a plus 0. And we can see that it actually went down 6. So in this problem, f of x translated down 6 units. So just by looking at this equation, we know that the graph is actually going to go down 6 units. So here's an example where we're not starting with the parent function. Here we're starting with a different function, and we're moving to g. So here we have a different y-intercept, and if I were to go from -3 to +2, I need to go up 5 units. So we say that g of x was translated, we'll say f of x was translated to finish with g of x. So we'll say f of x was translated up 5 units to create g of x. Okay, and so let me just give you a visual of what's going on. So f of x, I'll actually, maybe we'll do f of x in blue, and then g of x I'll keep in red. So f of x is x squared minus 3. That just means it's going to be a parabola. It's going to cross down here at 3, and so it kind of looks like this. Okay. If I look at the graph of g of x, I'll go ahead and do that red. Its y-intercept is +2. So you can see that if I start with the blue and I move it up 5 units, I now have the graph of g. And so we just say g is a translation of f of x moved up 5 units. Finally, we can describe translations in terms of function notation. And so this just means instead of using the actual equation, I'm going to use its name. Okay? So who cares what the equation is? We're going to call the red one g of x, and we're going to call the blue one f of x. And so this says we're writing g of x. So it says write g of x. So g of x should be the final product. Okay? G of x is where we're ending. And so if you notice on the graph, we started then with the other function. So we're starting here with f of x. And if we could pick f of x up and move it down, see if it'll let me move it down. If we could move it down, it's going to go down a certain number of units. And we can look at the graph to count how many units it would go down. So if we start here with f of x, we go down 1, 2, 3, 4, 5 units. So f of x went down 5 units. And so this is an equation that would take us from f of x and end with g of x.